Today, we want to discuss about our topic here. Chapter 11, File System. File system is the most visible aspect of an operating system. It provides a mechanism for online storage of and access to the both data and programs of operating system and all the users of the computer system. The file system consists of two distinct parts. A collection of files, each storing related data, and a directory structure which organizes and provides information about all the files in the system. File system live on device, which we described in the preceding chapter and will continue to discuss in the following one. In this chapter, we considered the various aspects of files and the major directory structure. We also discuss the semantic of sharing files among multiple processes, users, and computers. Finally, we discuss ways to handle file protection necessary when we have multiple users and we want to control who may access files and how files may be accessed. Hello guys. As we discussed in introduction of chapter 11, we have objective here. Here is the objective file system. First, our objective here is to explain the function of file system. Second, to describe the interface to file system. Third, to describe file system design trade-offs, including access methods, file sharing, file locking, and directory structures. And finally, to explore file system protection. That's all for our objective here. Bye. Hello guys, we meet again. Today I will discuss about my subtopic here. File concept here. File concept. If we look at this file concept, we must think the computer must be involved in this scenes. So I will tell about file concept. Computers can store information on various storage media such as magnetic disks, magnetic tapes, and optical disks, so that the computer system will be convenient to use. The operating system provides a uniform logical view on stored information. The information system abstracts from the physical properties in its storage device to define the logical storage unit, the file. Files are mapped by the operating system onto physical device. These storage devices are usually non-volatile, so the contents are persistent between system reboots. A file is a name collection of related information that is recorded on secondary storage. From a user perspective, a file is the smallest element of logical storage. That is, data cannot be written to secondary storage unless they are within a file. Next, file represent programs, both source and object forms and data. Data files may be numeric, alphanumeric, or binary. Files may be free form such as text files or may be formatted rigidly. In general, a file is a sequence of bits, bytes, lines, or records, the meaning of which is defined by a file creator and user. The concept of file is thus extremely general. The information in a file is defined by its creator. Many different types of information may be stored in a file source or executable program, numeric or text data, photos, music, video, and so on. Sorry guys, I have some problem here. Okay, the last paragraph is a file has a certain defined structure which depends on its type. A text file is a sequence of characters organized into lines and possibly page. A source file is a sequence of functions, each of which further organized as declaration followed by executable statements. An executable file is a series of a code section that the loader can bring into memory and execute. That's my subtopic. Let's go to the next person. Bye.
My subtopic is file structure. File structure is file type that also can be used to indicate the internal structure of the file. First, the object files have structures that match the expectation of the program that read them. Further, certain files must conform to a required structure that is understood by the operating system. For example, the operating system requires that an executable file have a specific structure so that it can determine where in memory to load the file and what the location of the first instruction is. Some operating systems expand this idea into a set of system-supported file structure with sets of special operations of manipulating files with those structures. Next, this point brings us to one of the disadvantages of having the operating system support multiplying file structure. The resulting size of the operating system is cumbersome. If the operating system defines 5 different file structures, it needs to contain the code to support this file structure. In addition, it may be necessary to define every file as one of the file types supported by the operating system. When new applications require information structures in ways not supported by the operating system server, problems may result. For example, assume that a system supports 2 types of file. Text file is composed of ASCII characters represented by a carriage written in line fact and executable binary file. Now, if we as a user want to define an encrypted file to protect the contents from being read by unauthorized people, we may find either file type to be appropriate. The encrypted file is not ASCII text line, but rather is appear line random bits. Although it may appear to be a binary file, it is not executable. As a result, we may have to recruitment or issue the operating system file types mechanism or abandon or our encryption scheme. Some operating systems impose and support a minimum number of file structures. This approach has been adopted in Unix. each file to be a sequence of 8 bytes. No interpretation of these bits is made by the operating system. This will provide maximum flexibility, but little support. Each application program must include its own code to interpret and input file as to the appropriate structure. However, all operating systems must support at least one structure that of the executable file so that the system is able to load and run programs. In the next subtopic is internal file structure. Internally, locating an offset within a file can be complicated for the operating system. These systems typically have a well-defined block size determined by the size of a sector. All this I/O is performed in units of one block is physical record, and all blocks are the same size. It is unlikely that the physical record size will exactly match the rate of the desired logical record. Logical record may even vary in length. Packing a number of logical records into physical blocks is a common solution to this problem.
Assalamualaikum. Today I want to tell you about my subtopic. My subtopic is file type. File type, when we design a file system in an entire operating system, we always consider whether the operating system should recognize and support file system. If an operating system recognizes the type of a file, it can then operate on the file in occur when a user tries to output the binary object from a form of a program. This attempt normally produce garbage. However, the attempt can succeed if the operating system has been told that the file is a binary object program. A common technique for implementing file type is to include the type as part of the file name. The name is split into two parts, a name and an extension, usually separated by a period. In this way, the user and the operating system can tell from the name alone what the type of a file is. Most operating systems allow user to specify a file name as a sequence of characters followed by a period and terminate by an extension made up of additional characters. Example include resume.docx, server.c, and readerthread.cpp. Consider the Mac OS X operating system. In this system, each file has a type such as .application. Each file also has a character attribute containing the name of the program that create it. This attribute is set by the operating system during the create call, so it's used enforced and exported by the system. For instance, a file produced by a word processor has the word processor name as its creator. When the user opens the file by double-clicking the mouse on the icon representing the file, the word processor is invoked automatically, and the file is loaded, ready to be edited. The Unix system uses a root magic number stored at the beginning of some file to indicate roughly the type of the file, executable program, shell script, PDF file, and so on. Not all files have magic number, so system future cannot be based solely on this information. Unix does not record the name of the creating program, and the Unix does allow file name extension hint. but these extensions are neither enforced nor depended on by the operating system. They are made mostly to aid user in determining what type of content the file contains. Extension can be used or ignored by a given application, but that is up to application programmer. The system uses the extension to indicate the type of the file and the type of operation that can be done on the file. Only a file with a .com, .exe or .sh extension can be executed. For instance, the .com and .exe files are two forms of primary executable files, whereas the .sh file is a shell script container. In ASCII format commands to the operating system, application programs also use extensions to indicate file type in which they are interested. For example, Java compiler expects search file to have a Java extension, and the Microsoft Word professor expects a file to are not always required. So a user may specify a file without the extension, and the application will look for a file with the given name and the extension it expects. Because the extensions are not supported by the operating system, they can be considered hints to the application that's operate on them.
Assalamualaikum guys, I will tell you guys about my subtopic, that is access method. Access method is a file store information. When is it used? This information must be accessed and read into computer memory. The information in the file can be accessed in several ways. Some systems provide only one access method for file, while others support many access methods, and choosing the right one for particular application and major design problem.
Bruh.
Come back guys. The next is sequential access. The simplest access method is sequential access. Information in the file is processed in order, one record after another record. This mode of access is by far the most common. For example, editor and compiler usually access file in the fashion: read and write make the bulk of the operation and a file. A read of operation read the next portion of the file and automatically advance a file pointer, which track the I/O pointer. Similarly, the write operation write next append to the end of the file and advance to the end and then of newly written material, the new of life. Such a file can be reset to the beginning, and on some system, a program may be able to skip forward or backward and some record for some integer and equal to 1. Sequential access, which is the PIC, is based on a tab model of a file and work on sequential access devices. It does on random access 1.
Bye, have a great time.
Hello guys, come back to me. The next is direct access. What is direct access? Direct access is another method. Is direct access or relative access. Here, a file is made up of fixed length logical record that allow program to read and write record rapidly in no particular order. The direct access method is based on this model of a file, since this allow random access to access any file and block. For direct access, the file is viewed as a number sequence of block and record. Thus, we may read block 14, then read block 53, and then write block 7. There are no restrictions on the order of reading or writing for a direct access file. Direct access files are great used for immediate access to large amount of information. Databases are often of this type. When a query concerning a particular subject arrives, we compute which block contains the answer and then read that block directly to provide the desired information. As a simple example, on an airline reservation system, we might store all information about a particular flight. For example, flight 713. In the block identified by the flight number. Thus, the number of available seats for flight 713 is stored in block 713 of the reservation file. To store the information about a larger set, such as people, we might compute an hash function on the file on the people's name or search a small memory in the index to determine block and read and search. Hello guys, and the next is the finally other access method. Other access method can be built on top of a direct access method. This method generally involves the construction of an index for the file. The index, like an index in the back of a book, contains pointer to the various block. To find a record in the file, we first search the index and then use the pointer to access the file directly to find the desired record. For example, our sale price file might lies in the universal product code UPC for item with the associated price. Each record consists of a 10-digit UPC and 6-digit price. For a 16-byte record, if our disk have 1024 bytes per block, we can store 64 records per block. A file of 120,000 records will occupy about 2,000 blocks. By keeping the file sorted by UPC, we can define an index consisting of the first UPC in each block. This index will have 2,000 entries of 10-digit search of 10 to 18,000 bytes, and then plus could be kept in memory. To find the price of a particular item, we can make a binary of the index from this search. From this search, we contain the desired record and access that block. This structure allows us to search a large file doing little I/O. With large file, the index file itself may become too large to be kept in memory. One solution is to create index for the index. The primary index file contains pointer to secondary index, which mean point the actual data item. Okay, so for the conclusion, the file type is an easy topic. You just need to understand the topic. If you can understand, then you can learn about it. So, what about I asking for my teammate? Okay.
Do it! Our topic maybe it's hard for you to understand, but if you search or you try to see the question deeply or answer deeply, you maybe can understand what this topic, because maybe I have not this with this topic, but I try to explain to you guys. So good luck for that. Maybe this video not good as another video, but we trying. Okay. That's our point.
How about are you?
Okay, my conclusion is so easy. If you don't understand about our chapter, you can just ask us and also lecture, okay?
Okay, that's all for today, guys. See you next chapter.
Bye. Have a great time.
Okay.
In conclusion, if you want to know more info about it, you must go to library, search internet to get more info about it. Because the topic is very hard. So if you want to know more, you must always searching what you want.
Okay.
That's all for me. Study hard. Macam mana? Hi, Assalamualaikum. My name is Anis Arvina. Bodoh lah. Hi, Assalamualaikum. My name is
Hi, my name is Aisha Kila. I'm from Science Computer and I'm from...
Hi, my name is Fikrullah,
My name is Ahmad Daniel and Muhammad Azmin.
and we are both from Computer
Computer
Science.
Science. Of and access to both data and programs.
Okay.
Assalamualaikum guys.
Nope.
Ya, ulang balik.
Assalamualaikum warahmatullahi
Ya, sabar.
1, 2,
wabarakatuh.
Ya, sabar.
1, 2,
Ya, ulang balik.
Okay.
Guys, today I want to discuss about our topic here, Chapter 11, File System. File system is the most visible aspect of an operating system. It provides a mechanism for online storage of and access to both data and programs.
Bruh.
Alah. Kau ada rasa ni tak kan? Okay. Sini lah. Macam tiba-tiba aku macam orang tak. Okay. Orang ni.
Don't let your dreams be dreams.
Bye, have a great time.